do have 5 people out.
Yeah, you talk about the review. Yeah, usually I try to make 2 or 3 extra in case somebody loses one or something, and this time I don't know why I have the exact amount. Just screwed up, I guess. On this review, on this first one, let's see here, change that 110. Number 1 says no normal distributions. Draw and understand the curve. One of the things I'm going to draw right here for number 1 is the curve. Remember, your mean's got to be right in the middle. When we draw these curves, I know one of them on the homework. I think it was on this homework, or it might have been on maybe I was doing it on something different. No, it was on this homework, I'm pretty sure. It was asking you to draw the curves. If your mean is 20.5 or whatever, and your standard deviation is 2.78 or something like that, for me, if you're going to draw this, just draw this. If we got 20.5, put that in the middle. That's your mean. And we want to go out 3 spaces each way for 3 standard deviations. These numbers don't have to be exact. All right? 2.78 is close to 3. Let's just go with that. So let's go 20, 23, 26, 29. Going down 3, 17, 14, 11. Does that make sense? I'm not looking for the precision here as far as, okay, this first standard deviation is this, the second one is that. As long as you remember, hey, this isn't actually one standard deviation, but it's something fairly close. All right? Some other things on drawing and understanding the curves. What do we know about the area under every normal curve? 1. So the area is always 1. When we're changing them into a standard normal curve, know the difference between a normal curve and a standard normal curve. Standard normal curve is where we're using z-scores. And this is always going to be 0, 1, 2, 3, -1, -2, -3. That's the standard normal. Know that not only is this your mean for the standard normal, but it's your median and it's your mode. So when it fits that normal curve, mean, median, and mode are all 3 the exact same. I wrote on there, know the percentages. When I say that, just have some idea. Does anybody remember what percent should be from there to there? 68%. Each one of these is 13% after that, right? Just some idea. What's that? That's 26 plus that. That's 26 plus is 94. So each of these is about 3%. Something close to that. Just have some idea. If you're 1 standard deviation from the mean on each side, you're 68%. If you're between 1 standard deviation and 2 standard deviations below the mean, it's 13%, so on, so on, so on. Number 2. I want to to start moving a little quicker because I actually want to do that review assignment. Be able to find the areas and the inflection points. Don't worry about that. We didn't do a whole lot with it. Finding areas, that's what we did for most of it. Standard normal distributions. I will write this. This is number 3. For number 3, remember the z-score equals, does anybody remember the formula? X minus mu over standard deviation. So if you need to find the z-score, that's how you do it. That's actually 3 and 4. Finding the z-score. Be able to use the chart. Did we use this chart a whole lot? If you don't have a calculator, you have to use the chart. I wouldn't use the chart, I'd use the calculator every time, so make sure you got one. All of these, when we were finding area, remember for number 5, finding probabilities, finding area and probability, it's the same thing. Same thing. Find the area or the probability, it means the same thing. So if they say find the area to the left of this number, it's the same as find the probability. And the reason for that is because the curve always has an area of 1. For number 4, where it says normal PDF, normal CDF, let's see here. I don't know where I want to write this at. I'll just write it here. If we're using the normal, whether it's PDF or CDF, remember there's certain things that you put in. If everything's on the standard normal curve, so if everything's in a z-scores, if in z-scores, you just put in your low and your high numbers. So if you know the z-scores, all you got to put in is the low and the high. If you're doing raw scores, so if you have raw scores, anybody remember what you got to put in then? The PDF, use PDF when you're trying to find, this is, I put this down at the bottom, use PDF when you're finding one value. So you're finding exactly one value. We want X to be 12. We want X to equal 12. All right? So I'll put example. X equals 12. That's when you use the PDF. Use the CDF. C stands for cumulative. So you use the CDF when you're finding a lot of values. Or, how do I write it down here? Cumulative, when you're finding total or something like that. So an example of that would be X is less than 17. So when we're finding from 17 down, so what I'm saying with all that is if we have, let's say, this is 15, 12 is right in here somewhere. If we're just trying to find the probability that you get exactly a 12, we're looking for just that area right there above 12. We use PDF. If we're looking for 17 cumulative, then we're looking for all of that area. All right? So we're looking for all of that area. I just laid that there. Number 6. Number 6, if you're trying to find the z-score. So, and actually it should say if you're finding a z-score or a raw score. Find the z-score or raw score. That's not supposed to be underlined for any reason. Then we're using the chart backwards, or on your calculator you're using inverse normal. So now you're saying, I want to know what score, and this is, we were just talking about ACT, this is how schools do this. They actually don't use the down though, they use the up, so let's change that. School like UC, mentioned that. They want an ACT score of, I think it was 29 to join their architecture program. So they set that at some point, and it probably changes throughout the years, because as ACT scores, the average goes up or down, they only want the top certain percent. All right? So let's say they don't, it's not a set number that's 29, that's what happened to be when I looked at it. But what they want is they want the top 25% of people who took the ACT, something like that. Well, we know the area here, the area is 0.25, that's what we're looking at. We're trying to find what score is going to give us that. And we use the inverse norm on there to find that. When you use inverse norm, does anybody remember what do you punch in? Just the area. Use the area if you're dealing with z-scores. You use the area to find the z-score. That's all you punch in. Inverse norm, we can also punch in, I believe, what is it, area, mu, and standard deviation. Is that right? If we're looking for the raw score. So if we're trying to find the raw score that fits that, we punch in the area, we punch in the mean, and we punch in the standard deviation. So if we're just looking for a z-score, you just have to punch in the area. If you're looking for the raw score, you got to punch in those 3 with the commas. That was number 7. Number 8, no percentiles. If I put this P 42, what percentile are we dealing with? 42nd percentile. And that means on our normal curve, what area is below that? What's the area of that right there? 0.42. That's all it is. All right? So 0.42. What if I have this? What's the area at P50? 0.5 or half? If we were doing z-scores, what z-score is at the 0.5 mark? What z-score has it? Half of the area below it? 0. All right. Let's see, use central limit theorem, sample means, be able to find 10, be able to find mu x bar. Remember, this is the mean of the sample means. Mean of sample means. What do you know about the mean and the sample means? It's always the same as the mean of the population. So Brendan's hoping I put a whole bunch of those questions on there where I tell him that the population mean is 247, and then I ask him to find the mean of the sample means. What is it? 247. All right. To find the standard error. Remember, this is standard error when it's sigma x bar. It's standard. It's supposed to be standard error, even though I call it standard deviation all the time because I forget. So that's the standard error. The formula for standard error. Does anybody remember the formula for standard error? Sigma over square root of n. What happens if our original graph looks like that? What happens when we start dealing with the sample means? All right, your graph's going to end up looking something like that probably. It's going to be more compressed. Be able to find probabilities, again, normal CDF. Remember, because some of the homework I know, some of the homework dealt with binomial stuff. Remember when we were doing binomial stuff last time, or last chapter, what you were actually finding, ignore that, you were finding the area of a certain bar. So if this was 0, this was, let's say that was 5, this was 4, this was 3, that was 6, that was 7, that was 8. And we wanted to find the probability that x equaled 5. We used that. We just found the area of that bar right there. So that's where we used the PDF. If we wanted to find x was less than or equal to 5, then we had to find 5, 4, 3, 2, 1, and 0. We had to find all those areas and add them all up. All right? Or we could have just used the CDF, the cumulative. Say, all right, we want to start at 5 and move down. Now you got to be careful because if I say this, you start at 5 and you move down. What if I say the probability that x is less than 5? Now are we including 5? So when we go to plug it into our calculator, do we put in 5? No, you put in what? 4. All right, you put in 4. So make sure you remember that and read the problems carefully. On the homework, that was some of the stuff that might have been a little more difficult. Explain what probability means. Is it unlikely? Remember, when is an event unlikely?
Two or more outside, two or more standard deviation.
Give me an area.
Area. Except within
It's unlikely when it's
outside.
less than what?
Less than.
Less than close. 0.05. Less than 0.05 or 5%. And if it's unlikely, if it's got a probability, it's less than 5%. Unlikely, less than 5%. Approximate a binomial distribution, number 13. This is some of the stuff that we just got done doing. So if we're trying to approximate a binomial distribution, remember we have to, if I said something like, find the probability that x bar, that's our sample means, is greater than 7. If it doesn't actually fit this, if we got to do the continuity correction, we just want the stuff that's greater than 7. So what are we going to tell the calculator? We're not going to tell it 7, because if we tell it 7, it includes the 7. And and we don't want it to, we want it to go greater than. So do we go to 8? That, we go to 8 if we were just doing a binomial, if we were just doing, you know, one step, but when we're trying to fit it to that normal curve, remember it's continuous now, so we don't just jump one whole number. What do we jump? Go up or down by 0.5. So instead of x is greater than 7, we're going to tell the calculator we want all the x's from 7.5 up. Because if this is 7 right here, then we're telling the calculator to go to right here, then start taking in all the area.
How do we put this in the calculator again?
That is still the normal CDF. And I'll show you here in a minute. So if we had something like this, let's try this one in the calculator. We want our x bar to be between 2 and 5. So do we want it to include 2? Do we want it to include 5? So what we got to do, we got to correct that so that the calculator knows, and we're saying, okay, we're not going from right here in the middle of this bar, we're actually going from right there on the edge of the bar and over this way. So we make these either go up or down by a half. So we go from, we want x to be greater than 2, so we go 2.5. Want x to be less than 5. So if we want to be less than 5, where would we go? 4.5. And when we punch it into the calculator, what do we hit? Second bars, normal, CDF, because we want the cumulative. Wish that pen would quit doing that. And what 4 things do we punch in? Low limit, high limit, mean, and standard deviation. Now, if we're turning it into if we're making it from a binomial into normal, and let's see, do I have this on here anywhere? Probably not. Approximate binomial, but so if we're doing this like it was on the homework, we're trying to make it into a normal. So if we're going binomial, changing it to normal, you've got to remember how to find your mean and how to find your standard deviation. Anybody remember what the mean is for a binomial? N times P. What's N stand for? Number of trials. P stands for the probability. So like 72% or whatever, 0.72. How do you find the standard deviation? Anybody remember that little formula? N times P times Q. How do you find Q? 1 minus P. And again, remember with this, when you're punching all this stuff into the calculator, if you're at raw scores, then you got to punch in the mean and the standard deviation. If you're on the z-score on the, like using this chart, we don't need that. We just need the high and the low. All right, looking at the review packet. We got about 20 minutes. Do you just want me to start at number 1? When we get down to about 7 or 8 minutes, you might say, okay, let's stop and let's do something. Skip through some of them. Number 1, what's half the area under a normal curve? 0.5. That's pretty easy. Half the area is 0.5. Number 2, draw two normal curves that have the same mean but different standard deviations. How am I gonna make these two graphs look different?
One's gonna be slimmer and one's gonna be wider.
So maybe something like that, and then something like that. Give me a number.
5.
5. What's gonna go right here then?
5.
Because they have the same means, but they have different standard deviations. How do we know that they have different standard deviations? One's more compressed than the other. Similarities. What's similar about these? We just said it.
Same mean.
Same mean. Give me something else. Both what? Both normal. Both normal curves. Give me some differences. Ignore that.
Slimmer. They're different sizes.
All right, so different spread. What else? Different what? What causes that different spread?
Different standard deviation.
Different standard deviation. Can I erase that? Number 3, find the indicated area under the standard normal curve using the standard normal table. Again, I don't care if you use the table or if you use your calculator. We're probably going to use the calculator, so have your calculator out to help me. Z equals 1.25. And for the first couple of these, I'm going to draw a little graph to show it. If we're using z-scores, what's right in the middle on the 0, 1 here, 2, 3. We're at 1.25. So we're looking right here, somewhere around that area. We want to know the cumulative area of all that down that way. Give me an idea before we actually use our calculator. What could that be?
80%.
80%? What do we know it's going to be more than for sure? 50%. If we come up with 0.32, what do we know?
Wrong.
We did something wrong. Nobody has an extra normal calculator, do they? I'll tell you what, I can use one of these. My calculator does different than your guys'. What are we going to punch into the calculator this time? We're trying to find this area, so what do we do? Normal, CDF, we could use the chart. Probably don't want to.
Area.
Do we punch in area? We punch in area when we're trying to find the score, right? So that's when we're doing it backwards. So this time, what do we punch in? Low. What's our low this time? Negative 10,000. What's our high end? 1.25. That's all we got to put in if we're on the Z chart. If we're on the standard normal. What is it? Doesn't sound good. So punch that into your calculator, see what you get. Say it again. 0.89. Let's go out one more spot. 4. Is that pretty close to what Katie guesstimated on a couple minutes ago? Yeah. B. We're going to do the same thing on B. Only this time, it says to the left of negative 0.5. So we're here, yeah, that's horrible. That's 0. Negative 0.5 is going to be somewhere right in there. So we want that area. What do we know about our area this time? It's going to be less than what? It's less than half this time. So what numbers do we punch into the calculator? Negative 10,000. What's our upper limit? Negative 0.5. What's that give you? 0.30. Give me one more. 8. So about 31%. About 31%. Calculator quit on me already.
The chart, I got 30% on that one.
Do what?
I got 30% on the chart.
Using the chart you did.
Yeah.
Next one, what's the next one say?
To the right.
This one's a little different. So watch closely on this one. Ignore that, because this time we want to the right of negative 2.8. Well, negative 2.8 is going to be somewhere way down here, right? And we want to the right. Can we just punch it into the calculator same way we did this one? What's our low limit this time? Negative 2.8. What's the high limit? 10,000. So we got to sort of turn it around. Otherwise, the calculator is always going to give you what's to the left. This time we want what's to the right. What'd it give you? 0.997. And think about it. Negative 2.8 is almost 3 standard deviations. About how much of the area should be above 3 standard deviations? Just about all of it, right? Above negative 3 standard deviations. What's D?
3.1 to the right of.
So we went to the right, so how are we going to punch that in? What are we going to put? 3.1, 10,000, good. Think about it this before you tell me anything. 3.1, that's way over here somewhere, right? I mean, that's way up there. How much of the area is going to be above that? Not very much, right? What'd it come up to be?
0.000968.
So about that. It's less than, not even 1/10 of a percent, right? E. What do we punch in this time? They give us both the high and the low, don't they? So what do you punch in? Negative 1.28 and 1.28. You just punch both those in. They tell you the low limit, they tell you the high limit. So we're saying on our little graph, we're going from here to there. We want to know the area that's in the middle of it there. What'd it come out to be?
799.
Before we even do that, what's the area between negative 1 standard deviation and positive 1 standard deviation? You guys told me a few minutes ago what percent's between those two. 68. So ours should be a little higher than that, right? Would you say it was, Lucas? 799. Is that a little higher than 68%? Yeah. Can always make sure that your answer makes sense. Negative 1.96 and 1.96. So we punch in those. That's almost 2 and 2, right? Oh, it's saying the other way, isn't it?
Saying to the left of
Right.
negative 1.96.
Ah, so they confused me. I should read the whole problem, shouldn't I? So we want this area and we want that area. How could we find that?
You have to do a separate column.
You sort of have to do them separate. Now, the good thing about the standard normal curve, what do you know about this area over here and that area over there if these two numbers are the same? The areas are the same. So really all we got to find is one of them and then multiply it by 2. So all we're gonna punch in, let's find this one, because that's the easiest one to tell the calculator. How would I find that area there? What's my low limit? Be careful. Negative 10,000, right? And what's my high limit? Negative 1.96. Find that area. What would that give you? 0.024, everybody agree with that? Then what are you gonna do with that? Times it by 2, so what's that give you? 0.049. That's pretty close. Number 4, find the indicated probabilities using the standard normal curve. So this time on number 4, 4A, they want us to find the probability that Z is less than 1.29. Same idea. You're still going to do the same thing. All we're looking at, we want Z less than 1.29, so if 1.29 is right there, which way are we going, to the left or to the right? To the left. So all we're going to do is tell the calculator what's our low limit. Negative 10,000, what's the high limit? 1.29. What's that give us? Area and probability, same thing.
Are we still using the normal CDF?
Normal CDF step. Yep. 0.901. Anybody else get that?
I had 1 zeros in my 10,000.
You what?
I messed up with the 10,000. I put 1. It was 100,000.
That shouldn't make any difference.
It was negative. It's what?
They give you the same thing?
No.
I got the same thing as that.
Should've.
I meant negative 0.098.
You're still using normal CDF, right? So let's try it again. Something's not right.
I got the same as him.
Second bars, punch in negative 10,000, 1.9. I'll bet if you got that answer that you just said, Miss Clark,
Never mind.
you
It's
forgot
negative.
the negative. Because the calculator's looking at that and going, how in the world do you go from 10,000 to 1.29? That's going the other way. That's not, something's not right. So it's giving you an answer that should never happen. Letter B, we want probability that Z is greater than 1.785. What do we punch in the calculator this time?
1.785.
And then we go over to 10,000, right? So punch that in, what's that give us? Give me a few numbers. 037, I'm sorry, I misheard you. 037. I'm not gonna write down the probability so we can hurry along here. What are we gonna punch in on the next one to get Z scores between those two? Punch those two in. 70 what? 6. D's one of them, again, they did the same thing to us. This time they want to go this area, that area. What do we really need to find? Just the one of them and then double that. So what numbers am I going to punch in to find this area? Negative 10,000, that's our low limit. Negative 2.9. And then you're going to times that by 2. Anybody else get that? 0.0037. Number 5. Monthly bills, mean is 250. Standard deviation is 35. Find the probability that a utility bill is less than $250. So we want probability that the utility bill is less than $250. We're going to do the same thing, except this time we're using raw scores, not z-scores. So what else do we have to punch in? Got to punch in our low, our high. What else? Mean, standard deviation. What's our low limit this time? If we're x is less than 250.
Negative.
Negative 10,000. What's our high limit? 250. You don't have to change this one because we're stopping right there at 250. It's not a binomial setup.
So wait, what do we use
Normal, normal CDF still. What goes next? 250. And then what's last? 35. Now, before you can punch anything in, you should have been able to do this without this one. Should have been able to do without punching into your calculator. We're trying to find the area below 250. Well, what's right here in the middle of our graph? 250. How much area is below that? Half of it. So what should your answer be? Better be 50% or 0.5. You could punch it into your calculator and check, see if it works.
Yeah.
B. Probability that it's between 175 and 225. What are you going to punch into your calculator? Normal CDF, 175, 225, 250, 35. What's that give us? 0.229?
0.2214.
0.2214. 22%. So 22% of the bills, about 22, should be between 175 and 225. Letter C. Probability the utility bill is more than 275. So more than 275. What are you going to punch into your calculator?
10,000?
Other way. What's our low limit this time? 275, then 10,000, 250, and 35. Because we want the area more than 275, so somewhere over there. What did it come up to?
0.2375.
So about 24% of the bills will be more than 275. Letter D. If 500 utility bills are randomly selected, about how many of them would you expect to be less than 220? So we want to find the probability that it's less than 220. What numbers are we going to punch in for less than 220? Somebody do this for me real quick. Negative 10,000, 220, 250, and 35. Then you're going to take that probability, whatever it is, and you're going to times it by 500. And that's going to tell you how many bills should fall in that range. Never know, maybe I'll be a nice guy next time and I'll put the test off and we'll finish going over this.
That would be awesome.
I don't know about that, brother. That's a waste of it. Try them, because don't count on me being nice.